can you solve this math challenge? Here's the question. So given this equation, a sub n equals n plus 2 over n plus 1 raised to the power of 2n plus 3, then the goal is to evaluate the limit of a sub n as n approaches infinity. Now pause this video right now and see if you can answer this question, because I will show you the solution in 3, 2, 1. Now given this equation, a sub n equals n plus 2 all over n plus 1 raised to the power of 2n plus 3, then the goal is to find the limit of a sub n, this function, as n approaches infinity. So now, the goal is to find the limit of this function as n approaches infinity, like this. And now, to answer this kind of question, what we're going to do is to focus on these two. Now, because these two, we can rewrite this as 1 plus 1. Now, what we're going to do is to separate this n plus 1 and positive 1. So using the concept of similar fraction. So we can rewrite this as n plus 1 over n plus 1 plus 1 over n plus 1. Now, n plus 1 over n plus 1 is technically equivalent to just 1. Now, from here, I see 1 plus 1 over n raised to some power. And this reminds me of this identity. If we have the limit of 1 plus 1 over x raised to the power of x as x approaches infinity, this is just equivalent to just e, or approximately 2.71828. Now, what we're going to do is to rewrite this in this format to use this identity, the limit of 1 plus 1 over x raised to the power of x as x approaches infinity. So, let's focus on this. And what we're going to do is to multiply this numerator by n plus 1 over n plus 1. So technically, this is just 1. So 1 times 2n plus 3 is just 2n plus 3. But we can rewrite this exponent as follows. N plus 1 multiplied by 2n plus 3 all over n plus 1. Now from here, let's focus on this result. Now, using some laws of exponent, we can rewrite this expression as follows. So the limit of 1 plus 1 over n plus 1 raised to the power of n plus 1 raised to the power of 2n plus 3 all over n plus 1 as n approaches infinity. And now, applying some rules on limits, we can rewrite this also, the whole thing, as follows. So the limit of 1 plus 1 over n plus 1 raised to the power of n plus 1 as n approaches infinity raised to the power of the limit of 2n plus 3 all over n plus 1 as n approaches infinity. Now, let's focus on this result, and what we're going to do is to evaluate this limit. The first one, inside this parenthesis, the limit of 1 plus 1 over n plus 1 raised to the power of the same thing n plus 1 as n approaches infinity is technically equivalent to just e. So this is just e. Now, let's focus on this. Now, how about the exponent? So what we're going to do here is to divide the numerator and the denominator by n. And if we do that, we get 2 plus 3 over n over 1 plus 1 over n. Now, here's the reason. Because the limit of 3 over n as n approaches infinity is just 0. And also the limit of 1 over n as n approaches infinity is also 0. So this is just e raised to the power of 2 plus 0 all over 1 plus 0. And 2 plus 0 is 2, 1 plus 0 is 1. And e raised to the power of 2 over 1 simply equal to e raised to the power of 2. And this is the answer to this question. So therefore, given this equation, a sub n equals n plus 2 all over n plus 1 raised to the power of 2n plus 3, then the limit of a sub n as n approaches infinity simply equal to e raised to the power of 2. And as always, we are done.